friends, in this video we will learn different types of set. Okay, the four basic types of sets. The first one is singleton set. As the name suggests, single. This particular set has only single element or one element. For example, it has only one, a number which is neither prime nor composite, we can say. Or one more set we already saw in the exercise was even prime number, which is 2. 2 is the only even prime number which exists. They are examples of singleton set. That means set with just one element. One element or single element. Single element. A set with single element is known as singleton set. The next major type is empty set or null set. Empty, as the name suggests, the set doesn't have any element in it. Okay. Not a single element, not a single element satisfying the given condition. So, we do not find any element satisfying the given condition for a particular set, then that set is an empty set or a null set. That means a set with no elements. For example, consider a set of negative integer which is greater than 0. So can we find any integer or any negative integer which is greater than 0? Because all the integers which is greater than 0 is 1, 2, 3, 4 and all of them are greater than, but none of them are negative. So every negative integer is less than 0. So we cannot find any element satisfying this condition. So my set will be empty, no elements in it. In other words, I can write it as null set. I can represent null set using either this symbol or just with curly braces and nothing inside it. Okay. Next basic type is finite set. Finite set. So what all sets come under this? Either the set is empty or number of elements are limited. That means a set is finite when either it is empty or we can tell how many elements will belong to this particular set. The number of elements are countable or limited. It has some restriction. Then we can tell that set is finite. Empty means there are 0 number of elements and either the set has zero number of elements, or one element, or two elements, or three elements, or four elements, or 100 elements. I should be able to tell the number of elements in the set, in the particular set. Or it should be an empty element, that means zero. Then it is finite. On the contrary to this, we have infinite set. That is the fourth basic type. Infinite means opposite to finite. Any set which is not finite is infinite. Is not finite means the elements are not, there is no limit to the number of elements that set can belong or that set can contain. Okay, so number of elements are unlimited. That means I cannot count the number of elements in that set, or I don't know how many elements will belong to it. There will be lot many, and it is unlimited. Unlimited means innumerable elements will belong to the set. We cannot tell a count or limit to that set. Then there are unlimited number. Okay, then it is infinite set. So any set which is not finite is infinite. Okay, so these are the four basic types of set. Now next we will see some examples. In the first video we had discussed some fundamental set of numbers, right? Set of naturals, whole. Do you remember? What was that? Natural numbers, whole numbers, integers, rationals, and set of real numbers. If you observe, all this set of numbers are infinite sets, because there are unlimited elements to all these sets. We cannot tell the number of elements belonging to each set. There are unlimited. We cannot count the elements in each set, right? 1, 2, 3 until infinity. All these sets are infinite sets. Now the next important topic is equal set. When can we say that two different sets are equal? Different set means I will take two sets and I have to match the elements in it. If all the elements match, then those sets are equal. So two sets A and B are said to be equal if every element in A is also in set B. I forgot, right? In set A. Okay. If every element in set A is also in set B, and every element in set B is also in A. So two sets A and B are said to be equal if every element in A is in B and every element in B is in A. And symbolically we will say A is equal to B. Okay? We will use equal to sign to represent, to denote that A is equal to set A is equal to set B. That means every element in A is in B and every element in B is in A. If you note, set of even prime numbers, that means same as this. So every element in A is in B, only one element is there, and it is same in both. So these here A and B are equal. Now we will consider another example of equal sets. Consider a set of first 5 natural numbers and b set of integers greater than or the set of, let's say, positive integers less than 5. So if you see, A is set of first 5 natural numbers. So 1, 2, 3, 4 and 5. And B is set of positive integers. So again this will start with 1 and which is less than 5. So again I will get the same set. So if you observe, every element in A is in B and every element in B is also in A. So here too A is equal to B. We will take few more examples. Is or such is such that listen and B and use some other letter. In the word silent. Let's list the set LIS and T. If you observe, L is in A, L is also in B. Now I have it on I also is there, S is also there, T is there, E is there and N is there. Similarly, S, I, L, E, N and T. So every element in A is also in B and every element in B is in A. So here also A is equal to B. That means A and B are equal set. One more example we'll see. X is prime. X is less than 8, and consider a set where not x, let's use y, such that y is odd and 1 less than y less than 8. So if you list both the set, what we will get? X is prime and x is less than x is prime means we'll start with 3, 5, 7. The next, okay, less than 8 means I have to stop here. And if I take this next example, y is odd and y is lying between 1 and 8. Odd numbers means y should be greater than 1. So I have to start with 3 again, 5, 7, and again should be less. So here also I get that A is equal to B. So now I think we have discussed enough examples, and when we will discuss the practice at 1.2, the concept of types of set and equal sets will be more clear. So stay tuned for the exercise. Thank you.